very excited to tell you a little bit more about the collaborative and co-marketing agreement with Protein Discovery on defining a workflow for intact protein analysis by high-performance LC-MS. Chuck told you about the gel-free molecular weight-based separation system, and the beauty of the quality of samples produced by this preparation device really enables nanobore LC-MS of intact proteins. Chuck showed this data briefly. This is just the overall system reproducibility on intact proteins. This is chromatography that you would probably normally associate with a peptide separation, but because all the interfering species are removed, all the adducts are removed, we can get a very high quality protein separation. So for 3 different LC-MS runs, we're getting a really high overlap, and that's pretty typical that they're getting between 30 to 50 protein identifications from a single LC-MS run. This gives you an idea of the high quality of the data. This is on a different gel-free fraction. 100% sequence coverage means essentially 0 false positives. There's a 7 times 10 to the minus 89th chance that that's not a positive identification. So that's, I think in my book, I'd call that heat shock protein, as opposed to the typical kind of bottom up where you just look at a couple of peptides. Quantitative electrospray, quantitative work really demands high performance. At New Objective, we've been working on actually higher flow rate electrospray sources. So we're normally associated with ultra-low flow rates. I think these newer sample prep tools combined with quantitative workflows means that our customers are going to be demanding to work in larger chromatography formats. And a larger format for us would be a 0.2 to a 0.5 millimeter ID column. So the source itself is targeting the sweet spot of operation from 1 to 20 microliters a minute. It's a very easy to use device. It's a probe-based system. There's a prototype right here. You don't need any tools or you don't handle fused silica directly. There's only a single connection to the column to make, and that's the connection between the emitter and the column. There's just a single connection to make. This is its operation for continuous flow at 20 microliters a minute with buspirone. Of course, that's obligatory. You can't come back next year unless you get one of those slides in. So we do a flow injection experiment to look at the robustness of the spray assembly. And we're doing a 2 microliter full loop injection from a leap with a 10 microliter a minute capillary pump on an LCQ Deca ion trap. This is showing injections 3200 to 3222, and the mass spectrometry looks more or less the same as it did on injections 1 through 5. This is the CVs for those peak areas from flow injection. They're quite good. They're all below 6%, and the average here is about 3%. So the first system that we're commercializing is for the thermo front end. That's the CSP 5500-650. That'll be available in the first quarter of 2010. We're going to be announcing CPSA pricing after the meeting, so pre-ordering will be available for this front end, and you can see a prototype in our booth downstairs. So thank you.